Imagine it's 1991. The web is just a tiny experiment. A scientist sends the very first request to get a simple web page from a server. That single request used a brand new protocol he invented, HTTP. Today, the same protocol, though much more powerful, is responsible for streaming movies, powering global apps, and delivering trillions of requests a day. Let's go back to basics and understand the protocol that literally built the internet. Ever wonder how your browser actually talks to a website's server? It uses a specific language, and that language is HTTP or Hypertext Transfer Protocol. Think of it as the official rulebook for conversations on the web. It's an application layer protocol, which is just a fancy way of saying it's focused on how applications like your browser should format and exchange data. Its main job is to transfer the files that make up websites, like HTML documents, images, and videos, from a server to your screen. HTTP is made up of two main parts, requests and responses. Let's start with the HTTP request. An HTTP request has three main parts, the request line, the headers, and an optional body. The request line contained three pieces. The method like get or post, which is the action this request is asking for. The path, the resource you're trying to access, and the HTTP version being used. Next we have the headers, which provides metadata about the request. Things like the content type, authorization detail, user agent, and more. Don't worry, I'll break these down in more detail later in this video. Finally, there is the optional body, which carries the actual data being sent, like form inputs or JSON when you're sending information to the server. Just like the request, an HTTP response also has three main parts, the status line, the headers, and an optional body. The status line includes the status code and the HTTP version. The status code is super important because it tells you the result of your request. Status code are grouped into 5 categories. Informational, 100s. These let the client know that the request was received and is still being processed. Success, which is 200s. These mean the request was successful. For example, 200 OK means everything worked as expected. Redirection, 300s. These indicate that the client needs to take another action like following a new URL. For example, 301 moved permanent. Client errors, 400s. These show that something went wrong on the client side, such as 404 not found. Server errors, 500s. These mean the server failed to process a valid request. For example, 500 internal server error. Next, the headers give metadata about the response, like the content type, cookies, or caching information. Finally, the optional body contains the actual content of the response, such as the HTML of a web page, JSON data from an API, or an image file. To get a better understanding of how HTTP works, let's see it in action by visiting a real website and observing the requests and responses in real time. I'll use the Chrome DevTools network tab to show you how HTTP works behind the scenes. So let's get started. After typing a website's name and hitting enter, you will notice a lot of requests appear in the network tab. Let's explore them one by one. The first request you will see is usually a GET request to the server that hosts the website, in this case, the Vercel server. This request is asking for the root HTML document, and it's always the first request made when visiting any website. If we look at the request headers, we'll see the three main parts we mentioned earlier. The method, which here is GET because we're requesting data. The path, which in this case is simply the root path. And the HTTP version, which is also shown in the request line. We'll also see other headers like accept, which tells the server what type of content the browser expects in return. And user agent, which describes the device and browser making the request. There are many other pieces of metadata in the headers that you can explore as well. Now, if we look at the response for this request, we'll find the status code. In this case, it's 200 OK, meaning the request was successful. The response header contains useful information about caching like cache control, the e-tag, which is used to check if the data is still valid, unless modified. The body of this response contains the HTML document for the page, which the browser then uses to start building the website. Next, we'll see other requests being made. For example, a request for the CSS file that defines the page's style. If we check its accept header, we'll see text CSS. Then there is a request for the JavaScript file, often called index.js or similar. Since this website is built using React, the browser needs this JavaScript file to render and make the site interactive. Finally, we'll notice several requests fetching the images used across the site, one by one. If we reload the page, something interesting happens. Most of the requests now return a status code in the 300s range, specifically 304, which means not modified. This means the browser didn't need to re-download the resources, because they were already cached locally and the cached versions are still valid. For example, the first HTML request now returns 304, indicating that the cached file is still good to use. You'll see this behavior for most static assets like images, CSS, and JS files. There are many more things you can explore and analyze about HTTP requests and responses, but this gives you a practical overview of how HTTP works in real life. And that's a wrap on HTTP basics. Now you know how every click, page load, and API call starts with a simple request and response. I'll leave some great learning resources in the description if you would like to dive deeper. If you found this video helpful, don't forget to hit like, subscribe, and share it with others who might find it useful. Thanks for watching, and I'll see you in the next one.